All right, folks, we're back at it again. I'm really excited about this lesson because we're going to put together what we learned the first day and the second day to actually use Trig to solve some problems. So the title of this lesson is Using Trig to Find Sides. So I'm going to go ahead and put that title up at the top of my paper. You want to go ahead and put the title up at the top of your paper as well. And again, hopefully you've taken some blank sheets of paper and stapled them together and made yourself your own little notes packet. All right, so I'm going to go back to some notes that we took in the first video, and I want you to remember those trig ratios that you need to memorize. Remember back on day one, we said that the sine value was equal to the opposite over the hypotenuse, that cosine was equal to the adjacent side over the hypotenuse, and that the tangent of an angle was equal to the opposite side over the adjacent side. Or S equals O over H, C equals A over H, T equals O over A. And the way I remember this, some old horse caught another horse taking oats away. Or sometimes we think about this as so ka toa. Regardless of which way you memorize it, and there are a lot of ways out there to memorize it, you have to know those three trig ratios. They're going to be really important in the lesson that we do in here today. All right, you will need your calculator for this lesson, so if you don't have it handy, go ahead, pause the video right now and go dig your calculator up. But I want to get down to business and jump right into this. Let's go have some fun. So in example 1, I'm going to start by drawing a picture of a right triangle. And again, if you need time to catch up, just pause the video and you can go ahead and take as much time as you need to draw your pictures. So I'm going to make angle B the right angle. I'm going to put vertex C up at the top, and I'm going to put A down here in the bottom right hand corner. And I'm going to tell you that in this triangle, I'm going to tell you that AC is equal to 26. And I'm going to tell you that the measure of angle A is equal to 38 degrees. And the measure of angle B is 90, which is a little bit redundant because we can already see from the picture that the right angle is at angle B. I want you to go ahead and I want you to find the length of side AB to the nearest tenth. So I'm going to go label the information that they give to me in the picture. The first piece of information that they tell me is that side AC measures 26. So I'm going to go to the picture and I'm going to find side AC. I'm going to label that 26. The measure of angle A is equal to 38 degrees. So I'm going to go to the picture and I'm going to find angle A. There's angle A. That's 38 degrees. Measure of angle B is 90. That's already marked by the right angle. They want us to find side AB. So sometimes it's helpful. I might even call side AB X. So side AB is this fella right down here. He's X. The first thing that I'm going to go do in my picture is I'm going to go label my hypotenuse, my opposite, and my adjacent. So if I go to the picture, I notice that 26 is my hypotenuse. The angle in the picture here that we know the measure of angle A is 38. So the side opposite from angle A, or across from angle A, is going to be my side BC, which means that my adjacent side is going to be X. Now, if I go back up to the top to my trig ratios, I notice that every one of these trig ratios only deals with two pieces. We either have the opposite and the hypotenuse for sine, the adjacent and the hypotenuse for cosine, the opposite and the adjacent for tangent. And sometimes what I've noticed kids will do in the past that they sometimes find very helpful is they'll take these and they'll write them down on a little sticky note, and then they'll move their sticky note from page to page as we work through the problems. But what I want to do is I need to look at the problem and I need to figure out which one of these three trig ratios I'm going to be dealing with. And this is sometimes the hardest part of the whole thing. Well, in order to do this, I'm going to take my highlighter and I'm going to go highlight. I know that my hypotenuse is 26. I know that my adjacent is X. And notice that my opposite over here, I don't know anything about. That opposite is not going to be used. So we want to use the trig ratio here that deals with the hypotenuse and the adjacent, or H and A. So I'm going to go back up here. This one deals with H and O. This one deals with H and A. This cosine trig ratio is the one that I want to use. So this question is a cosine problem. Not going to use sine, not going to use tangent. We're only going to use cosine. So cosine, remember, is adjacent over hypotenuse. It's always the cosine of our angle. So our angle here is 38 degrees. So cosine of 38 degrees is equal to our adjacent. Well, our adjacent is x over our hypotenuse, which is 26. And now that I've gone ahead and I've substituted or plugged into the ratio, this is where I'm going to go ahead and use my calculator. I'm going to go grab my calculator, and in my calculator, I want to find the cosine of 38 degrees. So I'm going to go ahead and dig out my calculator, and you should too. I want to open up a new document. No, I don't want to save it. Notice that in the upper right-hand corner, I'm working in degrees. I should always check that. But I want to do cosine of 38 degrees. So on my paper, in place of cosine of 38 degrees, I'm going to type in 0.7880. And I will always use 4 decimal places. Always. So this is 0.7880. and I'll always take the first 4 out of the calculator, equals x over 26. I'm going to put this over 1 so that I can go ahead and cross multiply now. So 1 times x is x. 0.7880 times 26, I'm going to go to my calculator to do. But watch what I do. I'm going to use the up arrow to go grab that 0.78 number, or in other words, to copy it. Notice how it's highlighted. And now I'm just going to hit enter and it'll drag that number down to the bottom next line for me. And I want to multiply that number times 26. It's very important that you copy and paste and drag this whole number down to the next line and don't just use the 4 digits that we put on our paper. And I think we wanted to round this to the nearest tenth. So when we round this to the nearest tenth, we end up with 20.5. So to the nearest tenth, side AB is going to be 20.5. Oh, we did a nice job there. Beautiful. So we were trying to find side AB. Side AB is the same as x. Boy, we're good. All right, I'm going to go up to the top of the next page because I'm out of room on this page. You might want to go up to the top of the next page too, or if you still have room to work, keep right on working away. But because I'm going to the top of the next page, I'm going to go ahead and some old horse caught another horse taking oats away. Or in other words, so ka toa. If you have those on a sticky note, just bring your sticky note to the top of the next page, but we're definitely going to want to have those handy as we work through these problems. All right, example 2. So this one too, I'm going to build a right triangle, but this one I'm going to draw kind of backwards. I'm going to call him A, B, C. Don't know how well that stuff got on my paper, but let's go ahead and get rid of that. I'm going to label angle B as 65 degrees. I'm going to label side AC as 12. And let's go ahead and in this question, let's find side BC. And this one too will round to the nearest tenth. So I'm going to label side BC X. Very first thing I want to do is go label my hypotenuse, my opposite, my adjacent. So hypotenuse is over here, right opposite or across from the right angle. There's my 65-degree angle, so my opposite side is going to be 12, which means my adjacent side is going to be x. So I'm going to grab my highlighter. I know my adjacent is x. I know my opposite is 12. I don't know the hypotenuse, so I'm not going to worry about that one at all. But I want now for this question, I need to make sure I use the trig ratio that deals with adjacent and opposite, or my A and my O. Sine, not going to work because I need O and H. Cosine, not going to work because I need A and H. The trig ratio that deals with adjacent and opposite is my tangent trig ratio. So that's the one that I'm going to use for this problem. So tangent of 65 degrees is equal to my O, or my opposite, which is 12, over my A, or adjacent, which is x. I'm going to go back into my calculator, and in my calculator, this time I'm going to type in tangent of 65 degrees. Oh my gosh, this is so much fun. Again, I'm going to put only the first 4 decimals down on my paper. You can put the whole thing if you want, but then it becomes very, very long and cumbersome. So 2.1445 That's over 1 is equal to 12 over x. Now I'm simply going to cross multiply again. So 2.1445x equals 12. Now I'm going to divide both sides by the 2.1445. So x is equal to, let me go to my calculator. I want to now do a fraction where the numerator is 12 and the denominator I want to be this whole 2.1445 number. So I'm going to go ahead and go up there. Oh, and notice that it didn't copy it where I wanted to copy it. So let me go back up there again. Copy that down into the denominator of my fraction. And I want to round that to the nearest tenth, so 5.6. Beautiful. Let me see how much room I have left on this sheet. Not so much, so I think I'm going to go up to the top of the next page. And I'm going to bring with me my SOHCAHTOA. And this is going to be my example 3. Ooh. So there's my right triangle. This time I'm not going to label any of the vertices. I'm just going to call this angle up at the top 50. I'm going to call this piece down here 15. And I want to find this piece down here. First thing I do every time is I go label my hypotenuse. So my hypotenuse is across from that right angle. Then my opposite is across from that 50. And my adjacent in this case is going to be the 15. So I've got the adjacent and the opposite. Let me get rid of that hypotenuse. I need to use the trig ratio that deals with adjacent and opposite. So with A and O. This one is O and H, so it's not a sine. This one is A and H. Our problem is not a cosine. Like the last example we did, this one too is going to be a tangent problem. So tangent of our 50-degree angle is equal to the opposite, which is x, over the adjacent, which is 15. So I'm going to go back to my calculator. I'm going to find tangent of 50 degrees. 1.1917. And again, I'm only going to put the first 4 decimals down on my paper. I'm going to put that over 1. So now x is going to be equal to 15 times the 1.197 number. So that times 15. And again, notice I drag the whole thing down to the next line. And let's round this to the nearest integer just to be different. So 18. And again, we're rounding to the nearest integer. Beautiful. All right, I think we're going to do one more. I'm going to go back up to the top of my next page. So again, there's my so, my toa, some old horse caught another horse taking oats away. This one will be the last one for today, folks. Let's make it a good one. All right, another right triangle. And in this right triangle, I've got 34 degrees up here. I've got 18 over here. And let's find the bottom of our triangle. All right, so there's the picture that we're working with. First thing I'm going to do is go label the hypotenuse. So hypotenuse, remember, opposite the right angle. So the side that's across from 34 degrees is opposite. Adjacent. So if I look at the pieces that I'm working with, I need the trig ratio that deals with hypotenuse and opposite. So there's hypotenuse, there's opposite. This is a sine problem. I don't even need to look at the other two. So sine of the angle, which is 34 degrees, equals the opposite, which is x, over the hypotenuse, which is 18. And I'm off to the calculator. Notice these are getting much quicker every time we do them. Sine of 34.5591 equals x over 18. So I'm going to put that over 1. So x is going to be equal to my 0.55 number times 18. So again, I'm going to go up to the previous line. I'm going to copy the whole thing down, not just the 4 digits I put on my paper. And we're again going to round to the nearest integer. So x is equal to 10. I love this lesson because we're using trig to actually solve some problems and to find some things. So this is really, really cool. You're going to use Castle Learning as the opportunity to kind of show Miss Andre and I what you've accomplished and what you've learned. So when you go to Castle Learning, the Castle Learning assignment that goes along with this video is the third assignment, which is called Using Trig to Find Sides. And if you get stuck, you can always email one of us. You can ask us during office hours. You can go back and you can rewatch the video and see if that doesn't answer some of your questions. You have lots and lots and lots of options. All right, we miss you all dearly. Believe me, we can't wait until we're back in the classroom, and hopefully it'll be sooner rather than later. But until then, we're going to keep on keeping on and just doing the very best that we can. All right, take care, folks. We really hope that you're well and can't wait to see you again.